up to 1,000 mil cable. Right. For those of you using the on-site guide, your on-site guides are limited on the amount that it actually covers. The regs book goes to a much deeper understanding. The regs book goes all the way down to 1,000 mil cables, and it also splits into three factors. The three factors at the bottom are to do with if you have a power factor and you're selecting a cable over 25 mil and you've got a power factor included in that greater than, say, 0.9. And you'd end up using all two of the values in there to work that out. If not, you go for Z. Okay? But that you'll cover more if you go for the level 4 design. Okay? So looking at my voltage drop, my column 3 was column 3, because we were looking at reference method B, aren't we? Yeah. So if we follow that down to 2.5 mil cable, 18. We've got the millivolts per amp per meter of 18, haven't we?
Yeah.
Okay, all happy with that? Yeah. So that's my millivolts. We know from our design that we're dealing with something that's 45 meters long. We know from the beginning that our design current is 13.04 amps.
10.56. 10. 10.5.
What does it equal?
10.
Everyone else gets the same point.
Yeah.
I just need to remind myself.
Yeah.
6.56.
10.156.
Okay. What voltage drop have we got?
10.6, isn't it? 10.5.
10.5 amps. Now, the regulation for voltage drop splits this down into two areas for us. It splits it down into lighting and any other power circuit. Okay. For lighting circuits, we're allowed a maximum voltage drop of 3%, which on a single phase circuit works out as 6.9 volts. And if we're looking at a power circuit, we're allowed a maximum of 5%, which works out as a maximum of 11.5. Does this comply with that maximum? Yeah, it's less, isn't it? It's near to it, but it does work out as less. So we can continue with our 2.5 mil cable.
What if it was 3 phase?
Then you'd be taking 400 and working out what the 5% of 3 phase is.
5% of 3%? 20. No.
5% of 400 volts. Okay? Which I think works out about 20 volts.
So,
Okay? Are you all still in the room still?
yeah.
Okay. So we've gone through all of this now. We're happy that we can install a 2.5 mil cable and it will deal with the life side of things, won't it? We haven't yet considered our earthing conductor now, have we? Not yet. So shall we work on the earthing conductor now? No. I've got one person shaking his head. They go, no, please. Okay. Have you all got on-site guides with you?
Yeah.
Could you please go to Appendix I in your on-site guide? This bit isn't in the regs book, but it's in the on-site guide for us to work off, and guidance note 3 as well. It's got the tables in the back of that. Okay. Yeah.
these anyway.
Okay. So, what route do we want to go down with our earthing conductor? We can actually cop out here. We can go down two routes for this. We can go down the route of, if you remember from last week, anyone remember the two routes? What route can we go down? There's two choices we've got for selecting our earthing conductor.
Can you choose what metal it's made out of?
You can choose like metal conduit and things like that, but that takes it into a whole other realm of calculations, which isn't expected at level 3. We've got the choice of regulation 50, what is it? 543.1.1 of the adiabatic equation. And what's the other choice that we've got? Table 54.7. Table 54.7 is a recommendation that you use for anything less than 16 mil, you use the same size cable. Anything 16 mil and above, you're basically looking at half the size of the conductor. Okay? So, what route do we want to go?
Where are you?
In the big book, page 198. If you remember that complicated looking table. I know, I'm just covering loads of information here for you. Right?
109, yeah?
Yeah, we covered this last week. Right. From that table, it tells us that for anything less than 16 mil, we can use the same sort of size conductor. That's why we can justify using a 2.5 and a 2.5. Okay. As it gets bigger, obviously, we have to change the size of the earthen conductor.
Bigger, okay, bigger.
Once it gets to a certain size, you can install half of its size. That's what it says about 16 mil and 35 mil and above. Okay, but that's lazy, isn't it? To just go to table 54.7 and go, do you know what? I could install the same size earthen conductor and I'll be happy with that. Okay, that's lazy, isn't it? All right, who wants to do that tonight?
Yeah.
All right. Or shall we go for a smaller size cable and see how it works out? I'd say you'd learn more from seeing how it works out. He doesn't know where he is. You can tell him we're in Timbuktu and he'd believe us right now. Okay. Who thought level 3 was going to be easy?
Fuck me, man. I tell you, man.
I never said to any of you it was going to be easy, did I?
You had said, yeah, it's a bit intense.
Yeah,
A bit intense. Yeah, mate. A bit.
We've all been there. I remember my week before my exam, where we had a similar sort of exam to what you had. I was spending that week in Magaluf. That's it. So every morning I was studying with my books in Magaluf because I had my exam on the Monday when I flew back.
Were you though?
What? I was actually, yeah. I'd pick them up, I'd look at them and go, oh, I'm too fucking hungover to look at that, and walk away.
I wouldn't fucking made on the airplane.
If it makes you feel any better, as Paul told you that he's not even going to be in this country when you have your exam. Right? That is actually true. Both Paul and Rob are actually flying out the country on that day.
So how do we benefit from that?
You don't. Right. Let's get back to this then. So, if we now go to table I1, sorry. Okay. Table I1 in the on-site guide.
It looks like 11, doesn't it?
It does look like 11. Everyone always goes, it's table 11, isn't it? No, it's table I1. Okay. So the first column tells you about the line conductor, and the second column tells you about the C.p.c. Okay. You can take multiple different sizes of cables and add them together to work out the resistances. The idea of that is if you're working on something like a type D breaker, you might end up needing to meet the disconnection time a 2.5 mil live and a 6 mil earth. It has been known to happen. Okay.
Majority are the same though, aren't they?
Yeah, quite often in a lot of circuits they'll be the same. But if you want to save a couple of pennies, you could install a 1.5mm earth on this, couldn't we?
Yeah, a lot for the space of the conduit, a lot of people go.
They don't like to because of the spacings. You want to be able to reduce some of the cores. So we're going to go for a 2.5mm live and the 1.5mm earth. What side? We've also got to choose if we're going solid or stranded for this, haven't we? Doesn't it say that on there?
No, it's copper or aluminium.
Copper, aluminium.
No, I'm thinking of a different table. Ignore me.
You're
I'm
thinking of the conduit.
I'm thinking of the conduit factors. It's been a while since I've done designing. Okay.
You'll bring that Magaluf, mate, that's what you'll bring there.
Booze and birds. Two of the biggest sins in life.
Long time ago. I can still remember.
It's got to be 12 years ago.
12. Yeah, I used to it.
I wish.
Yeah.
So, 2.5mm and 1.5mm earthen conductor. What is my milliohms per metre on that? On that table?
19.51.
19.51. Now there are some correction tables for this. Okay. We've got table I2 which looks at temperature, and we've got table I3 that looks at the way in which it's been grouped, the earth. Now, we've already taken temperature into consideration when selecting this size of cable, so we don't have to include it again. But what we do have to include is from table I3, the grouping of it. Okay. So this is a 70-degree cable, which has been grouped. So we're looking at the line that says incorporated in a cable or bunched. Because it's been run, this is where everyone goes, but it's not incorporated in the cable, it's single cores. Right? It's that last piece where it says bunched. Because the cores are in the same conduit, they are bunched together, aren't they?